Hello and good evening, and welcome to the RTS Technical Colloquium, and thank you for joining us. This year's Colloquium has already seen three excellent speakers. On Tuesday, David Walker from AWS gave a fantastic account of the methods and protocols of moving live media into the cloud. On Wednesday, Ethan Kovacs from Sky discussed how Sky are using the cloud to improve its sports recap products and how AI and ML are being used in real-time sports. And also on Wednesday, Rob Oldfield from Salsa Sound discussed the new opportunities cloud processing is providing to enhance the immersive experience and how AI and ML data mining is being used for metadata creation. Today, we have four outstanding panelists, all experts in their fields, and who will be helping us understand how to send live media into the cloud and process it in real time. We have Tracie Mitchell, Managing Director at Greenfish, Tim Burton, Managing Director at 755, David Walker, Senior Elemental Specialist Solutions Architect at AWS, and Russell Trafford-Jones, Manager, Support and Services at Techex. If you have any questions as we continue, then please submit them in the questions window, and we'll put them to our panelists at the end. So one of the things I've been thinking about when we're trying to move live media into the cloud is latency. And I know it's a hot topic. Some people love it, some people don't. And I was going to start with David by just asking you, is low latency really an issue? And what do we mean by low latency?
So low latency can be an issue. Generally, when you look at low latency, depending on your use case of it. So most encoders, when you use things like AVC or HEVC, you'll find that there'll be added latency because there's a look ahead window on the encoder. Also, when you're doing the think of it like the encapsulation of the video. So when you're putting it into whether it's SRT, RIST, or anything like that, there's going to be retry methods. There's going to be buffers and points in there. And I think some of the you can tweak those, you can do that, but then what's the trade-off between sort of ultra latency and reliability? I think that's a lot of the time people are having their arguments around is they want the super low latency, and you get to a point, and you can flip it around, you can flip it onto the distribution side of it. You can go for incredibly small segments on your HLS output there, but can the players handle it? Are the people watching the stream actually going to get a consistent playback rather than some buffering, some stuttering? I think, and that's the trade-off in the situations you get when you talk about low latency. It's at what point do you draw the line in there between low latency and stream reliability? I think that's one thing that's really contention, well, really a discussion point, actually, I feel.
Okay. Tim, do you have something to say on that?
Yeah, nail on the head when it's about everything's a trade-off, right? So whether it's efficiency of compression, giving it a bigger window to work in, means you can have more efficient compression with it. And I think it's also, as an industry, we often conflate delivery to consumer versus in the production chain. So to be honest, the consumers can and do endure a much longer latency, because of, there's a massive benefit in getting a very high efficiency delivery, great picture, smallest amount of bandwidth, keep your kind of CDN costs down. Conversely, in the production chain, because there's only a relatively small amount of consumers, we could run at a higher data rate. And actually that's where we want a lower latency when you say you've got a remote vision mixer or a remote production team, and you want a fast turnaround back to the, talk back to the cameraman. You don't want to be like, oh, can you pan back to that? Oh, it was 20 seconds ago. That's where low latency is kind of key with it.
Okay, thanks. And Tracie, do you have something to add?
I do, yes. I think Tim's hit on it there, actually, is there's lots of different points of processing as we're moving the media through the chain from source to consumer. And it can be frustrating, again, from just a media delivery point of view, is we're having to also chop the media up into different sizes to put them on different, network streams. And I think that's one of the things that I'm looking at the moment with new technology that's coming out, is how can we streamlined that that it's from source to consumer in a single network, and adaptive bit rate on the end, the consumer end. There is technology that's beginning to sort of look at this, which is interesting, right? I think we need to look at those different methods through the whole chain, right, from source to consumer.
I mean, there's a question, right, also of latency as a relative or an absolute term. Obviously, absolute is how long it takes. Relative latency is actually what the consumer feels. So if you remember in the football, when you had people watching the SD stream and you were on the HD stream, you'd hear the house across the road go, yeah, and you'd be like, what? Oh, the goal kind of thing, and it's that function. Now, obviously, there's things like, live betting in sports and stuff like that. I was at a motorsport event the weekend gone. There was a live stream of it. It must have been minutes behind, 3 minutes behind. But 99% of the people consuming that will not have known that. It's only the people that can hear the tannoy and see the screen, which is a very, very select few with it. So it's more about kind of the context of the latency.
Okay. I'm finding this sort of issue interesting, because a lot of the time now is you're having the consumers engaging with the content, and they're on the graphic systems, so they're getting data before the broadcast stream has reached them, and they're getting their tweets, or they're getting that type of analytic information before, and they're watching the big screen. So that can sometimes cause a problem.
That could be solved, right? If we kind of said, everyone worked to a unified 45 seconds of latency. Obviously I appreciate it's harder in betting because that would create an issue. But when you've got a companion app that's showing you lap times, or it's showing you in-play data, that kind of thing, it wouldn't be the wit of man for them to say, right, all the other chains are delayed by up to 45 seconds, to then create that relative latency would then feel non-existent with it. That's the key thing. But as I say, it's latency for someone consuming at home is very different to, say, latency where you've got an editor whose edit station is in the cloud, and they are in Beaconsfield editing that. They're going to be very sensitive to latency from the video that's going to stream from the data center to their TV or broadcast monitor, because they're trying to cut to music. They'll want something that's very, very low latency, because there's a real reason for that. They'll have a tolerance to latency in the frames, not the seconds. Conversely, a VOD platform is going to be in the seconds because of how the packaging works.
Okay. And Russell, what are your experiences in this?
Well, of course, around the home, you've got a similar problem, but it's if your partner's watching the same match upstairs and you're downstairs, then it's a big issue. Just walking room to room, and there have been technologies to synchronize this, but as you say, that making it uniform and bringing everyone on board is not going to work really. But within for companies which are able to deliver a full service, shall we say, multi-room into the home, there are ways of synchronizing which are important. And of course, it's always going to be an advantage, a commercial advantage, if you can say you'll get the goal earlier, you'll hear the news sooner. News is always quite interested in getting things out quickly. So I think it's really difficult to bring in. There's no real financial incentive, unfortunately, to bring in that a unified aspect unless it is a real benefit to the consumer, and that's going to be making sure that they can walk around their house and it's going to sound sensible. And I think the other thing to mention is that when we're talking about really cutting the latency down, and bear in mind that broadcasters seem to have taught themselves out of going sub-second in general, and there may well be technical reasons for that in terms of scaling. But there's an important difference when we're delivering things like CMAF, which is files essentially to the home. As a streaming provider, that your viewers are seeing exactly what you want them to see. You may have put a lot of effort into making the video look as good as it does with as fewer bits as possible, and that could have cost you a lot of money, but they're seeing it and they're seeing exactly. Now, if you start delivering with sub-second latency, you start to have to deal with the fact that it's going to have to start concealing or just dropping frames, just like video conferencing does. And that's going to impact the viewer's experience. And some broadcasters just aren't going to be willing to put up with that. Some will, and it's all part of your proposition, your quality, and what people expect out of your brand.
I suppose it's when we used to put tennis from the US through an alchemist when you're going from 30 to 25, a long time ago, the tennis ball would disappear because it would just get interpolated out because it just fell foul of the algorithm kind of thing.
Okay. So Tracie, you were saying there's some lots of technology going on in looking at latency. What kind of things did you have in mind?
So I've spent the last sort of 6 years looking in other verticals and looking at other technologies, because I've got a little bit frustrated with, my background is I build TV stations and do the solution design for that. And every time I do this is, I'm building another disparate set of technology systems, bolting them all together to deliver a single output. So I've been looking at blockchain and networking for that. I actually walked away and worked for a blockchain consultancy, and we delivered a network to the automotive industry. And in that learning, I was streaming data out of a car to an insurance company, and that was giving me sort of in real time. And this was giving me information that I could directly sort of translate into the broadcast world, right? Why can't we do that with media? So there is, there's technology that's beginning to grow and beginning to look at this particular problem that has, these distributed networks, basically.
I think the interesting thing here is trying to find the answer. Because I don't know what the answer is, whether it's second latency is acceptable or a minute or whatever. I come from a analog broadcast background where latency was unheard of in the very early days of PAL and NTSC distribution. And then when we went to MPEG, we sort of talking about half-second latencies, and then we put buffers on the input of the vision production switches, and we had another half-second latency, and all of a sudden, we've got to 1 or 2 seconds latency. Then we stick it over a satellite, there's another second of latency. But I think the difference then was everything was happening at the same time, so it was a relative change, and that didn't matter. The challenge we have now, as you say, with analytics and social media engagement, is there's a big race off, and that's a real challenge. What do you think about that, David?
So I completely agree with Tracie around sort of looking at other areas of the world and the other areas of business and see how you can bring it in. It's like some of the things I see coming through is there's loads of stuff coming through from the high performance computing area of the world. They're kind of, when you've got that instantaneous shares and stocks, and that's got to be accurate, that's got to be incredibly quick, and you've got to do that. And you get into things like, without going into kind of huge about things that you can get into, things like SRD, which is scalable, reliable datagram, which is something they invented in high performance computing to make sure it was 100% acknowledged data transfer. And they're the sort of things you see, and they're incredibly clever. But I do also agree with what Russell was saying and Tim was saying around locking the streams together. You see some very innovative things coming out about watch party technology now, so you can sit down with all your friends at home and watch the same Netflix locked in, so you can have the chat next to each other, and that's becoming incredibly popular. And I think with some of I agree, it's like with the latency, particularly around news and sports, you want to be there fast, you want to be quick on it. And I do see a way of I do see a possibility of them thinking, should we basically tie everybody to 5 seconds latency, or should we, depending on what device you're on, what connection you've got, we lock you down to there? But then you end up with the trade-off there. If someone's got an incredibly slow connection, or they've got a terrible player or something like that, are you delaying everybody else? But there's a lot to discuss, and there's a lot to think about this. And I think we could probably spend hours talking about ways to do this, or new technology. And then like blockchain, I need to look into it more, because I find it incredibly interesting. But seeing how other industries do things and bringing it into broadcast world is very good, is I think a good way of learning from other people and not making the same mistakes. I think is the main thing.
Okay. I've just seen a message come here from Tim Marshall, and he said, it reminds me, in the analog days, not so much latency, but we did get out of sync sometimes when the video went by and the sound on a microwave and the audio and video took different paths, and there was a lip sync error. So, we used to talk about lip sync errors a lot. And now I think, I don't know, is it calmed down? Is it any better or any worse?
Well, also frame delays are expensive, right?
Yeah.
The reason why things weren't delayed is because we couldn't, at a sensible space with it. I think there's two things, right? I think users are also starting to understand that they have a shared responsibility model in their home experience. If they don't want to suffer latency or dropout or that kind of stuff, they need to work with their broadband provider and ensure that they're in that space and it's not buffering. And you can see that's represented in the adverts, that we see going out with it. The other thing is that as an industry, we did have a tendency to take current technology and try and cram it into tomorrow's technology. So all of the ST2110 and wanting to run everything uncompressed, and PTP and all of these things that massively spiked the knowledge that was required. And if you look at, say, how YouTube or someone else, they're not going to bother with PTP. They don't need that level of timing and precision. In the same way, in analog days, you had to run reference out to the cameras, and then as the vision mixers got more capable, it's just like, we'll just synchronize the frames on the input to the vision mixer. Technology advanced, and it just made it redundant to have to sync something on the end of a long cable.
Okay, Tracie, do you have a view on that?
I totally agree with that. I think we're trying to shoehorn, technology. I think we've reached a ceiling with the current technology that we've got. I don't really think that it's going to get any better or faster or more efficient. And maybe we're looking in the wrong area, right? Maybe we're looking in, should we be thinking about where the storage is first, right? And actually think about, if we could find networks that we put files in once and then shard that content globally, and that might make everything more efficient. And this is my interest, right? This is where I'm sort of thinking that there has to be another way of delivering content to the consumer that's not so difficult to process and package it and put it in place ready for them to consume. Still we've got archives that we can't get at, right? Because they're inside somebody's broadcaster, right? And it's so much processing to get it out. Let's find a single network.
And head hours, because it's on a substrate we can't restore. I mean,
Exactly,
I'm a complete rank amateur when it comes to blockchain, but as far as my kind of knowledge is it's about immutability. Immutability of a transaction, immutability of the data that's put inside that with it. And what that brings is that you could potentially take data from untrusted sources because you can guarantee them, the integrity of the data. So, there's a case of, CDNs or that kind of delivery, is there I know it's almost like Napster kind of come back with it, but, more peer-to-peer, or is there a different kind of structure for how that works?
Yeah, there's a little, something called IPFS, which is connected to the blockchain, which is a ridiculous name, but Interplanetary File System. Right, and again, you can put content in that once, and then globally, people can access it if you've got the keys and permissions to get to that content. And so this is again fascinating. And there's blockchain companies that are beginning to pop up. One's called Storage. That is, I'm beginning to sort of think that's like a Dropbox type thing. Again, you can put the content in there, and it's efficient, and anybody can get to it if you've got the keys to get to that content. So. I think we're on the cusp of seeing, transformation of our technology stack,
I think
If we're
also
going to
it's live.
talk about if we're going to talk about new technologies and looking at things differently, I think that absolutely blockchain can be used and in parts of the chain. And as you're talking about immutability there, Tim, you're quite right. And media asset management, etc., is very important aspect of that. I think that if we're going to deliver, though, wherever you're going to deliver it to whomever, they're going to have to watch it on a screen, and getting it there within the minimal delay is going to be tricky with those types of methods. But one thing that can easily be done, I think increasingly with TVs and personal devices showing things to you at 120 frames a second on the screen, I think there's room to start thinking about making timing more flexible. PTP has its place when you are trying to put together very mixed together signals which have to be co-timed, and you want to split essences apart. But you don't want to do that when you're delivering to the home. What you want to do is just get a picture on the screen. And if you get it 20 milliseconds late, then I don't know, you've still got time to show it, haven't you? And if you've got 120 hertz or something like that, you've got a variable frame rate on some devices as well, then I think that allows us a little bit more play in the decoder. And it might be just enough to allow better reliability. And sure, there's a little bit of a cost in terms of how smooth it looks. But I think we might be surprised at how much that doesn't matter. And at the end of the day, perhaps that's better than a repeated frame or some sort of concealed error.
Yeah, I mean what we seem to be sort of moving to here is keep the data in the cloud for as long as possible. I think as I was watching your recording on Tuesday, David, and I may be misquoting you here, but I think you said words to the effect of moving live media to the cloud is now easy. Did you say that, or did I mishear you?
I did say that. I did say that, and it is easy. It's easy to do, but as Tim said, it's if you've got a huge archive, it's going to be time consuming. It's going to take time and effort to get it in there. One of the big constraints when we start talking about low latency and live video and 211022, for example, there is the bandwidth required for that. You can't do it over an internet connection. You need a dedicated fiber, you need a direct connection, you need something like that to do it. And I personally still think there will be hybrid workflows around for a very, very long time in this situation there. But I think a lot of the content you'll see is, as you said, that the VOD assets, the archives will be in the cloud. They will be it cloud storage, be it different types of storage within the internet, they will be there. But I think getting it there is easy, but it might just take you time, is my opinion.
Yeah, I mean, I suspect, I suppose one of the challenges I have with my my sort of thought processes in the cloud, and I'm purposely not going to ask you this question, David. Let's ask Russell. Russell, do you think by moving to the cloud, we effectively mean moving to one vendor, one supplier, and that means we're putting all our eggs in one basket? Do you think that concerns people?
Well, I think that broadcasters have always wanted an A plus B. They wanted a main and a backup, and there are so many ways of doing that. And I think that I think at the moment, I know that many broadcasters don't maximize their use of one vendor, just because it does cost money. It costs money to be constantly moving data between different regions or countries, or however you want to look at it. But at the same time, though, we're at a stage where everyone's dipping their toe in the water, so to speak. Some people are putting a lot of money behind it, don't get me wrong, but it's a first time for most of the major broadcasters, multinationals or otherwise. So this is the beginning. Sometimes they've got to the position where they're putting their full delivery chains in the cloud. Often they're starting with DR, and either way, though, this is the first time. There's loads of tools available. There's loads of tools within each cloud provider. There's lots of ways in which you can put it all together. And I think that we need to wait a little bit for that confidence and those initial projects to become mature, and people are going to naturally start saying, well, hang on, this is all very well, but I'm a bit worried now. And the point is, if they haven't spent the money to make it as resilient as they could do within one cloud provider, then of course at some point they're going to get stung, because that's why you have backups. Now, there's obviously other good reasons why you should want to be able to deploy in different areas, different cloud providers. And so it'll be interesting to see, once that confidence does come, how people will address that. And it may be that they find themselves locked because a certain provider has qualified all of their stuff in one, vendor has married themselves to one cloud provider, and it may be that some of their technology they haven't taken the time to broaden out. But that will come. I'm pretty sure of that. It's an intention, but I just don't think people are quite ready to do it.
Yeah, I think there's some part of me that thinks there's a big psychological thing going on here, because you think back to traditional broadcast facilities. You were locked into a sound console, you were locked into a production switcher, you were locked into infrastructure DAs. Yes, you could go and change your production switcher from one device to another if you really had to, but making one production switcher work is a pain. Then swapping it out and making another one work is even a greater pain. And I think the reality of the situation is rarely done, if ever. What do you think, Tracie? Is that sort of the right line to be going on, do you think?
I do think that this is going to smooth out a little bit. I think one of the main things is we're right at the beginning of looking at this new way of doing it. But on the point of having not being locked into technology, is a blockchain network can be compatible with another blockchain network. So like an Ethereum virtual machine means that it's actually compatible with another blockchain that is an Ethereum virtual machine. So again, that means that if you put content in one, you could use a second blockchain to actually access the content. Again, that would sort of bring efficiencies when we start thinking about a global CDN, for example, or that type of layer. What's missing, to Russell's point in all of that, is there's no software applications to enable us as an industry to start taking advantage of that tech stack. Right? There's no MAM on top of Ethereum. There is no editor on top. So at the moment we're at the bottom of the chain again, of being having to reimagine workflows and processes in order to enable this fancy technology to support us getting content to the consumer.
I think it's because as an industry, right, we have a relatively, media overall is actually quite small, and we have massive amounts of data. So when you talk Ethereum is literally, Ollie has this much money, the actual piece of data is tiny. It's not terabytes of media that you're wrapping up, and it carries a high, other industries carry a high value to data thing. Our value to data size isn't great. That's why it can be expensive in that space with it.
Yeah, I think the storage layer of the Ethereum part is this interplanetary file system that's connected directly to these EVMs. So again, you could put your content in that type of storage and use any blockchain to get to it. And I'm just finding this, it's a fascinating subject to be able to try and reimagine. What my background actually is from operations. Sometimes I don't actually care about the technology, is can I get the media through it? So, and process it for people. So this is where I'm finding, business benefits and efficiencies are coming with this new technology, which are worth us looking at, right?
When the big challenge is live, right? Because anything that's pre-recorded, films, that kind of stuff, is preceded and essentially just has an embargo date. They don't wait. They go, oh, quick, get it out. It's out. It's pre-cached into your skybox, and then once it's good to go, it's good to go. So really we're talking about live sports, live events, that kind of stuff. And what we're talking about here is so far removed from an OB truck or a fly pack that's going out to a piece that is still largely baseband with it. Now, okay, there are some, say, some of the smaller events, you know, people going out with cameras equipped with live view boxes, using 5G uplinks, going to, you know, various cloud-based vision mixers where they're bringing graphics in, and that's actually then being pumped straight into YouTube or into other kind of platforms at that kind of more, you know, club sport level of stuff with it. You know, I think it'd be very interesting as an industry to take what's being done at that mid-tier and kind of supercharge that, fuel it, and scale it to something that can work. Now, you know, I'm sure, you know, the guys at Sky and Discovery and others, you know, are doing just that with it. You know, they're clever people. You know, but that's where things like latency come in and stuff like that. And that's where the question of picking the right tools for the right tasks, you know, comes in.
Yeah, and
Russell, sorry, I'll just come to you in a sec, David. Don't worry, I will bring you in on this. It's Russell. Thank you.
Yeah, I mean, to kind of come around to your other point, your original point about multi-cloud providers, if we're going to be picking that best of breed, it may well be that there'll be certain things in one cloud provider which are better than others. It's going to be perhaps difficult to string them together, but if we're going to get to that stage where that's in some way practical, we need to think perhaps about the way that the broadcast industry, let's call it, engages with standards in terms of providing standardized APIs, for instance, to access certain types of service, so that it's a lot more practical for a broadcaster to, you know, if it's to use a certain type of service, and whether that's accessing a frame of video or a file or something else like that. If there was that abstraction layer agreed to and adopted, then it would make, I think, everybody's life a lot easier, as standards tend to once they, you know, get hold.
David,
I was just an idea popped in my head listening to Tracie. I just wondered, like, using blockchain and IPFS, how many copies in the world do you reckon are there of Game of Thrones, or how many copies of each individual Marvel film are stored in everybody's MAM or everyone's storage? You envisage a world where Disney have it's set in IPFS, and the person that's got it in the right time just connects their packager to it, and it provides the particular output they need. There's no masters sat on everyone's S3 bucket or in anyone's on-premise storage. Imagine the sustainability changes and the things you can make there, because I can't imagine how many copies of Avengers there are sat on various storages all over the world. But
4,800.
Yeah. But to the point as well, I think as Russell said, it's the live's going to be a big challenge there, and I think that's going to be with the standards, and I want to see what's coming next. I'd like to see what's next in there. We're seeing low latency coming in this year, a lot more pushing on low latency things like HLS and Dash for delivery to end customers. But yeah, I think I completely agree with Russell that some standardization or some methods of doing that would make make everyone's life a bit easier. I think the best way to describe it is, in my opinion, how I think about it, is just make everything interoperable, and that would probably make our lives a lot easier, rather than having protocol, because we've all worked in baseband, we've all done different bits and bobs. It's like protocol converters and things like that. That's what people tend to put patches. That's what we do in the industry. We put patches, or we build something to do a specific job. So yeah.
It's almost like we're sort of encouraging some sort of open source type approach to this, isn't it? It's is that a fair comment?
I'd like to think so, yes.
Okay.
I'd like to think so, because again, the industry that I'm mixing in is totally open source, right? And it means that you've got hundreds of thousands of engineers working on the same problem, right? And they want to deliver that problem to the industry so that it's the best for the whole. Again, whereas we as the broadcast industry, we're actually a small industry, aren't we? Engineers. So this is again important, I think, that we allow, you know, hundreds of thousands of people to be able to contribute to a single problem. And the interoperability sort of statement there that was coming up is, even in that, I'm beginning to sort of see smart contract as our workflow engine, logic, as the logic to enable interoperability between different blockchains. So that if you want to trigger something, then this smart contract will do that. And those are our standards in this new world, right? In this new industry. Again, the engineers are defining those standards of how a particular smart contract will work.
Yeah, I'm a big fan of open source in terms of the standards. It's just that we still need a standards, perhaps not a standards body, but an industry body, nonetheless, to kind of codify what it is that we're all going to work towards. But opening that up and doing that in the open, I think is an important step. Sorry, Tim, I think I spoke over you.
No, it's all right. I think. So often there's a question of, do you bring the standard first and then do open source, or do you do open source that drives the standard? And what I'd say is that classically with standards bodies, what they've done is gone off and tried to appease everybody, these designed by committee type things. And then people look over the fence at it and go, it's a lot of ball ache to kind of integrate all that. Whereas the good thing with open source is that by and large, it is agile by nature. So people only invest in developing what they have a genuine value to. So it tends to grow much more organically. But also as an industry, we're not big open source consumers. You know, even the bits of open source that we do consume tends to then be wrapped up by a vendor and has a blue and silver badge applied to it, you know, and sold, you know, that bolts into something. I mean, how many times have people rebought FFmpeg? So, you know, even things that you'd think would be very, very, you know, would be a great thing to open source, like the core of a MAM engine, right? You know, just the very core of indexing files, you know, something that can keep a data structure in it, something that can interoperate with that. You know, but yet more MAMs come out, you know, every week with it. You know, that and interoperability isn't a big thing with it.
It's actually the process around a MAM as well, right? Is a MAM is still a static piece of software on a lump of storage, right? It's actually more about the workflow around it. Get media into MAM. Can I QC it? Can I present it to an editor? It's that logic that we need to also agree on, because that also comes with a different vendor, which then locks you into those particular processing, you know, capabilities that the user needs.
I mean, vendor lock-in, right? And this might be a slightly contentious point, is that I see a lot of people who try and avoid vendor lock-in at stage one. And I often say complexity is like complexity to the power of systems, right? The more systems you bring in, it just exponentially grows in complexity, right? And people will quote to me, oh, but, you know, Netflix have moved out of Amazon, or Dropbox moved out of Amazon with it. And you're like, yeah, when they're at the scale where they've got more devs that there are people in the media industry with it, for the moment, focus on functioning. And then, you know, if you get to a scale where you're getting torn a new one, then look at porting it out as a separate project. I see too many projects that failed because they tried to maintain interoperability. You know, you go back to the days of like BBC and the DMI, when they were trying to make it work with every NLE under the sun and have like a unified interchange. Nice idea, but it was boiling the ocean from an integration perspective.
We still do that inside every broadcaster, right? Is, you know, like when I try and design a system for somebody, I'll say, let's try and do 4 systems max. And then, you know, it ends up being 6 or 8, which means that it's still a problem, even internally, to have interoperability just between software sets.
Well, it's a bit like a lock, right? You know, if you've got three numbers, you know, you've got, you know, 1,000, you know, different codes. You add a 4th one, it gets harder, and by the time you've got 57 tumblers, it's very, very, very complex. You know.
I think the locking idea is quite interesting, because one thing I was instantly thinking there is security. IP security, it's a big thing. We never used to have to worry about it that much in television, because you knew when somebody was hacking your network because they had a pair of wire cutters in their hands. Now, there could be anybody from the other side of the planet hacking your network. And one thing I would say for cloud providers and lock-in is that you've got an entire company of incredibly knowledgeable and intelligent security people who are completely dedicated to protecting that network. What is that a fair assumption, David?
It is a fair assumption, but there's also you said this earlier, Tim, there's a shared responsibility model. So you can have, as default out of the box, most AWS services come incredibly locked down, and then you have to open it up. So there is a shared responsibility model. If you talk about S3 buckets, they're defaultly private. It's up to you whether you make them public or you create that. So there is a shared responsibility model. The physical network security and the default network security, absolutely, there are teams and teams of people looking after that, and they will make sure that there are never any problems there. And they're also very good at noticing if you have some problems or there's something specific going on there. But there's nothing to say that you can't have an EC2 instance, open it up to the world, and someone gets into your S3 bucket, or someone does that there. There's always going to be the capability for human error. And you get things like, there are almost all cloud providers have a service where they can say, right, this is our default agreed by the security team, this is our default compute profile, only these ports will be open to these IP addresses, and that's how they deploy them. And then there are monitoring software that if anything diverges from that, it will either snap it back or it will notify somebody who do that. But a lot of the time, the best way to think about it is a shared responsibility model. It is you're only secure as the weakest point of it. And if you make an S3 bucket public and someone finds it, there's not a lot anybody can do about that. Or if there's a EC2 instance open to the world with no security on it, you're gonna have those. You're always gonna have those problems. It's the same things when you had firewalls at data centers or broadcast centers. You realize that, I remember going to somewhere and someone had cross-patched something, and they basically connected their corporate network to their broadcast network. And you're kind of looking at it going, how's nobody noticed this yet? And it's like, yeah, it's security's an interesting one, but it's an incredibly important one. And I think we could probably spend another 45 minutes talking about security in broadcast networks as well as in the cloud here. But the best way to think about it is it's a shared security responsibility. It's a shared responsibility model, and we work together with people to do it. And that's the same for most all cloud providers.
Well, security was easier in a round connector world, SDI, because of the fact it was obscure. Whereas now you're in a world of of IP. It is more kind of ubiquitous. Now, yes, you could misconfigure a bucket, if you don't know what you're doing, and have broad access, people can access to it. But you could also do the same thing with a firewall with it. And I think the difference now is, I think people are waking up to the fact that four-wall security is not as well rated as it used to be, because you have to patch and maintain this stuff. And the new thinking is your perimeter isn't safe. People move horizontally within the organization, and and how you work in that space with it.
Indeed, it's a matter of looking at what your exposure profile is, and of course, it is going to be increased when you are increasing the amount of networking you do. But it may well be that you are much more susceptible via the human element in reality, and it may well be that you potentially the biggest cost to your company is the fact that you're displaying it on someone else's device. And as long as you're going to show them the picture, then there's some way out through streaming. So I think it's easy to get hung up on it, but the positive side, which is often not really mentioned, is that you can shout out your public key as much as you want, and I can share all my one-time passwords as long as I've used them once. I don't have to worry about that. It's not like I'm playing a gambling game. These are things which are mathematically secure, and you just need to make sure that your company is following the procedures and doing it well. Sometimes it won't, and you've got to have balances against that. But that's the same with everything that you do through your configuration of your broadcast kit as well. Sometimes it won't be configured right, and the program won't go out right. You'll have the wrong commentary. Something will go wrong. So it's very much a process which needs to be throughout the whole company, and starting with the humans, and also taking a realistic look at where your security holes are most likely to be.
Tracie, I'm sure security is core of what you do.
High on the agenda.
Yes.
Yeah.
What are your views on this?
I do think we've created a security industry because of our technology, stack at the moment. We still have disparate systems which requires us to put security around it. So it creates an industry that's important that we protect the content. Again, archives, and I'm thinking about that, is surrounded by security. With the networks and everything that I'm working on, it's built in, right? So immediately with the private keys and the access models into these networks, security it's on steroids, really. It's cryptography all the way. And if you haven't got the keys to get into that, to view a particular piece of data, you cannot do it. Also, the network will detect malicious attacks, right? Because the network is self-learning, and it will find a rogue entry into it and alert the rest of the network. So again, this is fascinating stuff.
Okay, Tim.
I think, a lot of this there's a lot to be learned from the IT department. We're talking about things like EDR, so endpoint, detection and remediation. It's been more proactive with this stuff. And, we're talking about the concepts of a broadcast network and a corporate network. Well, we often used to separate them because we didn't want to elevate the broadcast network to the same level of security that the corporate network ran to, because it would slow it down. And I remember going into places and they'd be like, right, if it's a Cisco switch, it's broadcast. If it's HP, it's, if it's Cisco, it's corp. If it's HP, it's broadcast, and by and large, broadcast networks would be giant layer 2 Wild West kind of things. We've learned that is not acceptable. And actually now we're starting to have to lift the broadcast networks in line with where the corporate ones are. These things are actually starting to merge together a lot more, is what we're seeing.
Okay. Well, we're just coming to the end. So I'd just like to finish with one more question for each of the panelists. And we'll start with Russell. And the question is, what is the biggest technological advance you've seen in recent months for cloud operations?
A very good question, because it's not easy to answer. I think that the importance of what we're doing in the cloud is finding all of those tools and applying them to what we can already do. It's a little bit like we're just saying about obviously learning best practices from the IT industry. That's pretty much all broadcast has been about for the last 3 years. Is like, we'll have some of your networking, we'll have some of your security. What about that cloud? And I think that it's going to take time to look through all of these things. So if we think about what we've learned from CMAF and HLS, taking a stream which is supposed to be linear, cutting it up and delivering it kind of linear, but not exactly, into the cloud or to the consumer, that's actually helped. That's been a massive boon, because we've understood how to do that already. Now, if we've also got it already saved, then so if we ever want to use those files again, we just re-access them. So traditionally, that's kind of been a bit dangerous, because they've all been small files, and thousands and millions of small files is not always a good thing. But there are file systems that can deal with millions and billions of files, but they're just not the ones we tend to use. And we're talking about this timing and reinterpreting what our video is. If we're using a codec which doesn't care about the frame by frame, we can split up every single picture into its own frame, all of the audio separately, and we can have billions of these files, and then we can treat them as a kind of continuum of files rather than rather than these kind of 2 10-second chunks. So, that lends itself, certainly after the fact, to all of these ideas of blockchain and immutability and storage. So at that point, we're able to much better harness the cloud. And we may well need the cloud for storing all of these the files. But we should be able to get advances in the way that we're going to be able to deliver more flexibly and more reliably the video, and also do more useful things with it in the meantime. It's easy on a frame-by-frame basis, if you have the whole frame, to process it, to add something to it, perhaps, to understand it, to run these analytics against it. So, and then lastly, the technologies like LCVC, which are computationally made to make it easier for computers to understand and decode the file, could all come together.
Tim, how about you?
Sorry, remind me of the question.
The question is, what is the biggest technological advance you've seen in the cloud in recent times?
See, I like the little things. So for me, the things I've liked recently has been NDI, specifically because it unlocked one major drawback. Obviously, PC over IP, I thought was magic kind of 5 years ago. Everyone knows about it, and it allows you to stream user experience. It's, people know, but the NDI element has now enabled us to do things like editing with a third monitor, with multi-track audio. And the key thing is, right, the plugin is free. The apps are next to free. Your converter boxes are so cheap they may as well be free. So it's brought a lot without a big cash grab, and that's why I think that's been a real game changer for us over the last 3 months.
Okay. David.
I'll go slightly opposite everyone. I'm liking recently the changes I'm seeing from lots of vendors around manifest manipulation and personalization of streams for end users. So instead of delivering different streams to multi-countries, what you do is you're clever with your ad markers and you use manifest manipulation or stream personalization to put in your regionalized adverts in there to splice out content you don't own the rights to. So you're not producing multiple streams, and you can do some very clever things. I've seen some use cases around where they can filter between devices, filter between countries. So a customer or a consumer can stream a stream from one country, and where the host broadcaster might have rights for that football match, you can put in a match that's a case there. I've also seen the stream manifest manipulation, relinearization of VOD. I think that's a big one there, is because you can create a lot of, instead of having these entire complex workflows, you can create a John Wayne channel for the day. You can create, you can do a Matrix, you can do a Russo Brothers, you can do all these really, really clever things really quickly. And also using like ESAM, for example, or using some SCSI 35 inserters in those points there, you can create what would in theory be movie channels with content you've got sat in the cloud or sat on your storage. And I think for me, consumer wise, is I think the more we can give them customization and personalization is good, in my opinion.
Excellent, thank you. And Tracie.
So I think it's going to have to be distributed ledger technology, right? Because I think that, regardless of the technology ceiling we might be at with the current, tech stack and stuff, I think it's time we started folding in financial transactions for everything we do with every service that we use. And that to me is, again, very interesting, because we're opening up the fact that we'd be able to monitor and track, all of the costs of processing, of delivering content, and also being able to pay, folk in real time for, using that service is, again, quite spectacular. So looking forward to trying to fold that into our networks.
Excellent, thank you. Okay, well, I'd just like to take this opportunity to thank all the panelists for a truly impressive talk this evening, and also to thank our speakers on Tuesday and Wednesday for their outstanding contributions. I'd also like to thank everybody who's contributed towards this week, and the RTS committee who have helped share this unique information. So please look out for the next colloquium, and hopefully it will be in person. Thank you. Goodbye.